Hello, welcome to Lecture 7. Last week, we studied logistic regression, which is the simplest neural networks. And this week, we are going to look at neural networks in more detail. And here, we see a pigeon, which is actually a pigeon doctor. So this week, we will start with individual neurons and then move on to simple neural networks. We will examine the decision boundary made by neural networks and also look at the features learned by neural networks. Finally, we study convolutional neural networks by looking at the basic operations and then examine it in detail. So we can actually train pigeons to be a doctor who can diagnose breast cancer. This is a YouTube video, shows the experiment. Basically, the scientists have shown some breast tissues to pigeon and provide some yellow bar and blue bars to indicate positive and negative, and reward the pigeon with food to train it to diagnose breast cancer. And they have been quite successful in achieving a diagnosis accuracy of 85% to 90%. So what is a neuron? Neuron accepts information from multiple input, and here is a neuron. From multiple input, it accepts the information, and then it will transmit information to other neurons. So this is a transmission of information to other neurons. Therefore, in machine learning, we model the neurons in a similar fashion, where the input are multiplied by weights along the edges, and then we apply some function to the inputs, weighted inputs at each node, and then transmit a signal, which is fx over here. So this is an analogy to the real neuron. And the axon from neuron is basically the input. And here is a dendrite, which will provide the input to our neuron. And this is synapse, which provide the weight of this input axon. And in the neuron itself, we do some computation, and there's an activation function to generate an output, in analogy to an output axon. So neural network is basically a network of neurons. And the simplest neuron we have seen is a linear neuron, which basically doing a linear combination of the input, as in linear regression and logistic regression. And then after the linear combination, typically we need to use an activation function to generate an output. Commonly used activation functions include sigmoid, which is what we studied last week in logistic regression. So this is what a sigmoid function looks like. Another choice is a hyperbolic tangent function look like this. But actually, the most popular activation function nowadays is called ReLU. It is much simpler and look like this. That is, for smaller than 0, it basically 0 out. And for greater than 0, it just it is linear. So it is basically a partially linear function. So which is very simple, but also very effective. So in order to learn in neural networks, we need to do some kind of computation. The first computation is called a forward pass. So in this forward pass, we make predictions or decisions based on the input. So this is the input. This is called the input units. And for example, here is a one hidden layer neural network. And so this is a hidden unit, and that is our output unit. So the forward pass basically takes the input and generates a prediction or a decision as the output. So if we plug in the input, we will do some multiplication, activation to get the output through the hidden layer edge. And there's another computation which is called backward pass. And this is the back propagation process for optimizing the model parameters, basically the weights and the bias. What it does is to compute the gradient of the cost or the loss or the error. So basically we use different names, but it all means the same thing, the cost function or loss function or error function. And they do compute the gradient of such cost function with respect to the weights, so that to find the good values for the weights to achieve a good prediction accuracy. And nowadays we use automatic differentiation, which is called autograd. And the basic principle is the chain rule. Here is a chain rule for univariate variables, and here is a multivariate chain rule. And you just need to know this to know the relationships between the output and the input. And then you can automatically compute the gradient to know like how to optimize your weights to have high prediction accuracy. So that is the basics about the neuron and how to do the computations. In the next session, we will move on to some simple neural networks.